Hello again, DeAndre Smith here, and this lesson is to show you the ins and outs to factoring. Now in this lesson we're going to cover how to factor using the distributive law. Also, if you have quadratic expressions, how to factor those quadratic expressions. And then lastly, we're going to cover if you have a expression in the difference of squares format, how to factor those. So I don't want to waste any more time, so without further ado, let's go to the board. Hello everyone. Again, this is a lesson on factoring. Now if you learned in prior lessons, we learned different methods of factoring, but all in all, factoring is a way of making something times something. So in this lesson, we're going to discover three topics. First, we're going to factor expressions by using the distributive law. Secondly, when our expression is quadratic in form, we're going to learn some methods as to how to factor those. And lastly, we're going to factor using the difference of squares method. Now let's start off by factoring using the distributive law. Now factoring using the distributive law is the most general form of factoring. In fact, it should be the first method that you apply before any of the methods that you learn today. So this is how we factor with the distributive property. First, we're going to break each individual factor within the term down to its most prime state. So let's break that down. So 3xy is the same thing as saying 3 times x times y plus 9 in its prime form is 3 times 3. So we'll say 3 times 3 times x. Now if you notice in both of the terms, they at least both have a 3 and an x. So we'll circle 3 and x. Therefore, we can group y and 3 together by saying they are both being multiplied by 3 and x. So we have 3x times the quantity of y plus 3. If we go back and check this answer, we can go 3y times y and 3y times 3, and we will end up getting 3y times y plus 3y times 3. Thus, this will give us 3y squared plus 9y, which is back to our original answer. So every time you factor, if you re-multiply it back out, you should always end up with the answer that you started with. That's a way of indicating or letting you know that you got the right answer or the right form of factoring. Let's look at another example. So here we have 2x to the 4th y to the 3rd plus 3x to the 6th y to the 10th. Now again, we are going to factor each of our terms in their prime states. So in our first term, we have 2 times x times x times x times x times y times y times y plus 3 times x times x times x times x times x times x times 10 y's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, in this case, both terms at least have 4 x's and 3 y's. So we'll circle those. So now we're going to put those on the outside. So we have x to the 4th, y to the 3rd, and what's left in our terms, well, in the first term we have 2 left, plus 3x squared y to the 7th. Again, we can check to see if we have factored correctly by remultiplying out our solution. So if we were to multiply out again, we get x to the 4th y to the 3rd times 2 plus x to the fourth y to the third times 3x squared y to the seventh. This gives us 2x to the fourth y to the third plus 3x to the sixth y to the 10th, which matches our original given answer. Now we're going to move along to factoring quadratic expressions. Now I know you all may be scratching your heads and saying, what is a quadratic expression? Well, a quadratic expression is anything that follows the format of ax squared plus bx plus c. Of course, a, b, and c are all numbers. We're going to learn methods as to how to factor quadratic expressions in two cases. First, when a is equal to 1, and then next, when a does not equal 1. In this example, we're going to factor this quadratic expression. And again, this is a expression where our a value is equal to 1. How do we know that it's equal to 1? Because nothing is in front of the x. So we can assume that the coefficient or the number that's in front is 1. So first we're going to write our parentheses out blindly. So in our next step, we're going to find factors of the last term that adds up to equal the middle term. So since our last term is positive 4, we're going to find all of the factors of positive 4. So we'll start with 1 times 4 and negative 1 times 4, or negative 4. Next we have positive 2 times positive 2. And we also have negative 2 times negative 2. Well, our middle term is equal to positive 5. So the only combination that's going to add up to give us positive 5 is the first combination. Positive 1 and positive 4. So therefore, that's what we put inside of our parentheses. Positive 1 and positive 4. We can check our solution by remultiplying the terms. So we're going to multiply x times the x times the 1, 4 times the x, 4 times the 1. X times x, x squared. X times 1 is x. 4 times x, 4x. 4 times 1 is 4. If we combine our like terms, we get x squared plus 5x plus 4. So our factored solution matches our original problem. So therefore, we know that we factored it correctly. Okay, let's look at another example. In this example, we have x squared minus 5x plus 6. Again, this is an example where our coefficient is 1 because there is no number in front of the x squared. So first, we're going to write our parentheses. In our second step, we're going to find factors of our last term 6, whose sum is equal to the middle term, negative 5. So we have positive 1 times positive 6. We have negative 1 times negative 6. We have positive 2 times 3. And we have negative 2 times 3. Negative 3. So our only combination whose sum will add up to give us negative 5 is negative 2 times negative 3. So therefore, we're going to put those inside of the parentheses. Now let's check our answer. We multiply x times negative 3. Negative 2 times x times negative 3. So x times x is equal to x squared. X times negative 3 is equal to negative 3x. negative 2 times x is equal to negative 2x. And negative 2 times negative 3 is equal to positive 6. If we combine our like terms, we get x squared minus 5x plus 6, which matches the same as our original. Now let's get into factoring quadratic expressions when our a term is not equal to 1. So in this case, we know that the a term is not equal to 1 because there is something there. So we have a 2 in this case. So to factor expressions where the first term is not, well, the first coefficient is not equal to 1, we're going to utilize the British method. So step 1 of the British method, we're going to multiply the first and last term. So that means we're going to multiply 2x squared times negative 6. So this is equal to negative 12 x squared. In our second step, we're going to find factors of the above term that adds up and equals our middle term. So let's write down all of the factors of negative 12x squared. So that means we have negative 6x times positive 2x. We have negative 2x times positive 6x. We also have negative 12x times positive 1x. We have positive 12x times negative 1x. We have positive 3x times negative 4x. And we have negative 4x times positive 3x. Well, we want our combination to add up to equal positive 1x. So the only combination that would give us positive 1x is the combination of 3x, negative 3x, times positive 4x. So we'll write here 2x squared minus 3x plus 4x minus 6. In step 3 of the British method, we are going to now factor using the distributive law. So what we're going to do is take the first two terms and we're going to factor them, and then we're going to take the second two terms, and then we're going to factor those using the distributive law. So this becomes 2 times x plus 2 times 2 times x. And then this side becomes negative 3 times x minus or plus negative 3 times 2. Well, on the first side, we can factor out a 2 in the x. So now we have 2x times the quantity of x plus 2. And on our second side, we can factor out a negative 3. So we have negative 3 and x plus 2. Our last step, we're going to group everything together. So we have 2x being multiplied by x plus 2. And we have negative 3 being multiplied by x plus 2. So therefore, we can group 2x and negative 3 into its own quantity. So this becomes 2x minus 3 times the quantity of x plus 2. And this is our factored answer. Now let's check our answer. So we're going to multiply 2x times x, 2x times 2. And then we're going to multiply negative 3 times x and negative 3 times 2. Well, this is going to give us 2x squared plus 4x minus 3x minus 6. If we combine our middle terms, we get 2x squared plus x minus 6. So our factored expression, once multiplied out, matches our original expression, and everything checks out. Now we're going to look at factoring expressions that are in the difference of squares format. So the difference of squares format means that it follows a squared minus b squared. Henceforth, notice the wording difference. Difference means subtraction. So in these problems, you're always going to have a subtraction sign. Also, another thing to consider is our coefficients are perfect squares. So here's what a perfect square is. A perfect square, well, if something is a perfect square, that means that this statement is true. Meaning I can multiply two of the same numbers to get it. So for example, a squared is a perfect square because I can multiply a times a, both the same numbers, to get a squared. Another example would be the number 4. The number 4 is made up of 2 times 2. Once again, the same numbers multiplying to give me an answer. What about the number 5? Well, this will not be a perfect square because I can't multiply any two numbers that are the same to give me 5. What about the number 6? Well, of course we have 2 times 3, but 2 and 3 are not the same numbers, so therefore 6 is not a perfect square. What about 16? Yes, 16 is a perfect square because we can multiply 4 times 4 to get 16. So let's factor this example. We have x squared minus 16. The first step is we're going to write the parentheses. So we're going to write our parentheses. And in the difference of squares expression, when we're factoring it, we're going to always put a plus and a minus in between. So in our next step, we're going to find the perfect square values of x squared and 16. Well, once again, if we go back to x squared, well, to get x squared, we know we had to multiply x times x to get it. So therefore, in our first values is going to be x and x. To get 16, we know that we have to multiply 4 times 4 to get that. So our second values would be 4 and 4. And our solution is completely factored. Now let's check our result. Multiply x times x, x times 4, negative 4 times x, negative 4 times 4. So x times x is going to give us x squared. X times positive 4 is going to give us positive 4x. Negative 4 times x is going to give us negative 4x. And negative 4 times positive 4 is going to give us negative 16. We combine our like terms. We're going to get x squared minus 16, which matches our original expression. Now here's an example where it appears to be in the difference of squares format, but it's not because we don't have perfect squares. Again, 8 is not a perfect square, 50 is not a perfect square. But what we can do is go back to what we learned as far as factoring using the distributive law. So first let's factor this using the distributive law. You have 2 times 2 times 2 times x minus 5 times 5 times 2. And if you guys are confused on how I am getting the 2 times 2 times 2, I'm finding the prime factorization of 8. So you may want to refer back to the prior lessons on prime factorization to see how to do this. But in both of our terms, we can factor out a 2. So we're going to bring 2 on the outside of our parentheses. And we're left with 4x squared minus 25. So now at this point, what's inside of our parentheses is a difference of squares because 4 and 25 are both perfect squares. So let's break down what's in the parentheses first. So we're going to write our parentheses, put our plus and minus. So we got to figure out what two numbers we can multiply to get us 4x squared. So if we go 4x squared off to the side, we know that 2x times 2x gives us 4x squared. So that's going to be our first terms. So 2x squared, 2x squared. And then our second term, we have to figure out what times what gives us 25, which we know is 5. So 5 times 5. So our second terms will be 5 and 5. Next question is, what happens to this 2? Do we just get rid of it? Well, no, we can't just get rid of it. What we do is we bring the 2 down. So our fully factored solution is 2 times the quantity of 2x squared plus 5 times the quantity of 2x squared minus 5. Hello? Again, I hope you guys have fun learning how to factor. This lesson was to provide the foundation of all of the different methods of factoring. As always, if you need any additional resources or any additional help, feel free to contact me. Thank you.